Okay, I have drawn out an AC circuit for you, and unfortunately it doesn't include a diode, but hopefully it can help you understand some of the basics of AC circuits and how they're different from DC circuits. So the first thing to look at is the voltage source. Um, the voltage source now has a time dependence, and the voltage will depend on time, and the voltage will be periodic. So it has this amplitude here, Vs in this case, okay, and that will change in time. All right, and so the next thing to talk about is impedances. So impedances are analogous to resistances in a DC circuit, right? So in a DC circuit we can write Ohm's law this way, right? V equals IR. But now down here we can see that we have a V equals IZ. So the impedance is kind of taking the place of the uh, resistance in an AC circuit. And similarly, when we're trying to find equivalent impedances, we can see circuit elements in series will just add together, and circuit elements in parallel will be this kind of little more complicated formula where we have a reciprocal. Uh, but actually, even though it looks more complicated in some ways, the rules for adding these circuit elements impedances in series and parallel to get an equivalent impedance is actually quite a bit simpler, because it doesn't really matter what circuit element it is, they all add the same way. So then I want to go to the bottom left part of the screen. So this is Z is impedance, R is resistance. That's the same resistance you're familiar with in a DC circuit. And then X is the reactance, and J is actually imaginary number I. Okay, so we use J to be equal to I when we deal with AC circuits, because we don't want to get we don't want I to get confused with current. So do not want confusion with current. Okay, that's an important thing to remember. So anyway, this is a basic like RLC circuit here. Something important to work with. On the next page, I wrote out explicit impedances for inductors, capacitors, and resistors. You'll notice the resistor is literally just the resistance. Those are important formula to remember for any test. I also wrote out something called a high-pass filter. So now if we analyze this, right, so as W approaches infinity, ZC will approach 0. Okay, so therefore, high frequencies pass in this circuit. Okay, so this is actually one of the most common AC circuits you'll see, and there's an equivalent circuit called a low pass filter, or there's I guess like an opposite kind of idea circuit called a low pass filter, where the resistor and the capacitant components in this circuit are swapped. So in that case, um, low frequencies will pass, but high frequencies will not, because this resistance or the capacitance next to the ground will become very, very high if W approaches 0. So anyway, that's kind of a brief overview of some of the basics of AC circuits. I hope this is helpful.